Good morning, everybody. Today, we're going to continue our conversations about global climate change, and we're going to focus on some of the effects of global climate change today. So let's get going. So here's our agenda for today. Last time when we had our Zoom call, Dr. Burl and I asked you guys what your questions were about global climate change. And I looked through all those questions, and I just want to answer maybe one or two of those today at the beginning of the screencast. And then we'll get into the effects of global climate change, specifically how coral reef ecosystems are affected by increases in ocean temperatures. And finally, I'll go through your assignments for today. One thing that I want to just note is that I looked through all of your homework comments in the discussion section of the portal, and I was really struck by some of your comments. All of you guys found that this graph in particular was really compelling because it shows that carbon dioxide levels are higher now than they have been in the last 800,000 years. Not only are they much higher now, but they're also increasing at a higher rate. Another thing that you guys mentioned in that discussion section of the portal is that you were struck by the relationship or the correlation between carbon dioxide and temperature. It's really tightly correlated, and it has been for the last 800,000 years. You can see that here because the temperature lines are the light blue colors, and the carbon dioxide concentrations are the dark blue colors. So you can see how close the relationship here has been for the last 800,000 years. So one thing we didn't talk about was, well, what's the impact of all of that extra CO2 that humans are adding on the global temperature? All right, we know there's a connection, but how much has temperature really increased? And so here's the answer. This is from the NASA website. And what they are showing is right now, temperatures have risen about 1 degree C, 1 degree Celsius, or 1.76 degrees Fahrenheit since the Industrial Revolution. And one thing that I noticed is that many of you asked at the beginning of our Zoom call, well, what's going to happen at this rate, right? How much longer will Earth be livable? This is a direct question from one of you guys, and many students had a question that was like this. So I just want to take a couple of minutes during our screencast today to see if I can address this question to the best of my ability, given the science that's available. So one thing that I'm guessing you guys are aware of is that there's something called the Paris Climate Accord. And this happened back in 2016 when many countries, about 196 countries, came together to make an agreement that was aimed to try to combat climate change. And here's what the agreement says. It says that countries will try and hold the increase in global average temperature to well below 2 degrees C, and to pursue efforts to limit the temperature increase to 1.5 degrees C above pre-industrial levels. So the goal is to try to keep the temperature increase below or at 1.5 degrees C. And why did they choose this as the goal? It's because that international panel of scientists, the IPCC, these are the recommendations that anything above that will potentially be catastrophic to ecosystems and to human populations. So that's the goal. And now I want to show you what the projections are. So the projections are showing that if we do nothing but what countries have committed to in their plans, and those plans only reach until about the year 2030, we are going to exceed the goal, right? We'll get to about 3.3 degrees C of an increase by the year 2100. And you can see here on the y-axis, this is global greenhouse gas emissions, right? And so what we're doing now and what the agreements are really not enough to get us to that 2 degrees C or 1.5 degrees C goal. So what can we do? So what this International Panel on Climate Change and the scientists that are a part of that, what they say is that we have to do more. And part of that doing more is likely needing to capture carbon dioxide from the air in order for emissions to go negative. So what does it mean to go negative? It means that we're probably going to need to come up with technologies, and this is happening right now, that capture CO2 from the atmosphere. And here you can see a picture from a company that's doing this. This is a company in Vancouver. What they're doing is sucking in air, capturing the CO2 from the air. And this company in particular is injecting the CO2 underground. Other companies are trying to turn the carbon into things like limestone that can then be used and sold. But this is really where we likely need to go in order to reach the goals of the Paris Climate Accord. So the Earth's temperature has increased about 1 degree C since the 20th century. What's the big deal? 1 degree C doesn't seem like a lot, right? Well, the reality is that small changes in temperature correspond to enormous changes in the environment. And that's one thing we're going to focus on today. But here's an example, right? At the end of the last ice age, when the part of the United States, the northeast part, was covered in about 3,000 feet of ice, the average temperatures were only about 5 to 9 degrees cooler than they are today. So let's talk about climate change and that 1 degree C increase in temperature and what that increase is doing to the oceans. We talked last time about how the added carbon dioxide in the atmosphere, we said some of it is getting sucked into the ocean. About 25% of that carbon dioxide is actually getting drawn into the ocean, and part of it's getting incorporated into the biomass of algae and other living things in the ocean. But that the same is true for the heat. The excess heat in the atmosphere is also getting drawn into the ocean. And so this extra heat and this extra carbon dioxide are causing a variety of different effects on the ecosystems in the ocean. The water's warmer. Because it's warmer, there's less oxygen in the water. And because there's more CO2, it's more acidic. And all of these things are causing the impacts that you can see at the bottom of your screen here. What we're going to do, or what you are going to do today, is investigate sort of what's happening as a result of warming ocean temperatures. And in particular, we're going to be going to coral reef ecosystems to look at what's happening there. So what's the effect of increased temperatures on our coral reef ecosystems? One thing I wanted to make sure you guys knew before you went off and completed your homework assignment for today, so I wanted to make sure that you guys knew what a coral is. So here's a trivia question for you. Is coral an animal? Is it a plant? Or is it a rock? What do you guys think? Well, the answer is actually all of the above. It was kind of a trick question. And here's why. So first, the coral themselves, corals are animals. The animals are related to things like sea anemones and jellyfish. Here's a close-up of one right here. If you were actually to look very closely at this coral head, here's what you would see. It kind of looks like a jellyfish or a sea anemone, and they've got stinging cells just like jellyfish on these tentacles right here. If you were to flip this coral polyp sideways, this is what it would look like. And what you can see right here is that they have algae that live inside of them. So really, corals have a mutualistic relationship. Remember, mutualistic relationships are a type of symbiotic relationship, right? Where they both benefit. So they have these tiny algae called zooxanthellae living inside of them. The algae benefit because they have a place to live and they have carbon dioxide that they can use to photosynthesize. And the corals have an extra source of nutrition from the byproducts of the photosynthetic algae. Okay, so that's, and by the way, I forgot to mention too, they're also a rock, right? So just like Clams and mussels can build their own shells. Corals also build their own shells that they live in. They draw calcium and carbonate out of the water. They build these calcium carbonate skeletons that the polyps live inside of. And calcium carbonate is just another word for limestone. So it's a type of rock. Okay, so that's why corals are both animals, plants, and also rock. The last thing I want to mention is, what is coral bleaching? I'm sure you guys have heard of coral bleaching events before, but really bleaching occurs as a result of any kind of stress. Okay, and what happens during a bleaching event is the corals, a healthy coral, like you can see it here on the left, they expel their zooxanthellae, the algae that's living inside of them. And when they do that, they don't have that color anymore. Their tissues are clear. And so you really can see through the tissue to the white calcium carbonate or limestone skeleton underneath. Okay, so that is what coral bleaching is. And I'm going to leave it to you guys to learn more about it by completing your homework. Okay, so here are your assignments for today. You're going to complete FTW 610. That's posted on the portal. And yes, I know I didn't go over the answers to FTW 6.9 today during our screencast. Instead, I posted the answer key on the portal as well. So you'll find it there. You can go back and correct your FTW from FTW 6.9 if you need to. And then your homework assignment is to complete your coral bleaching assignment and post your answers to the discussion on the portal. Now, I want to quickly show you what that assignment looks like. So I'm going to have you guys go to this website. It's called Data in the Classroom. And you're going to launch the activity by clicking right there. And once the activity comes up, here's what it looks like. I'm going to have you guys complete levels 1, levels 2, and part of level 3. This is all laid out in the portal, so you don't have to remember it. I tell you this in the portal. But here's one thing I really want to show you guys about how this interactive activity works. Right? So you read everything by scrolling through the activity in level 1. And you can see that there's a window here that's going to change. And the window actually will show you all sorts of different data. But the cool thing that you should know is that these windows are interactive. And so you can definitely click inside of them, move things around. Of course, my web browser is going really slow right now. But just make sure that you guys know that everything that's within this big window is interactive, and you can zoom in, you can zoom out. There should be tools that allow you to interact with the data that you can see in these windows. So you're going to go ahead and do level 1. You're going to do level 2. And you're going to do part of level 3 as well. Only the part through right here. So you're going to complete this part that says identifying the effects of bleaching on coral reefs. You don't have to do anything beyond that piece. Okay, so I hope that's helpful. The last thing that I want to mention is, beyond doing your homework assignment, don't forget your ecology projects are due next Tuesday or Monday, depending on which block that you're in. And make sure that you remember that there's a few things you need to do to turn it in, right? So you're going to complete the online self-assessment. You're going to run it in through Turnitin and make sure you review your score. Okay, so that's it, you guys. If you have questions, remember you can email me or you can email Dr. Burrell at any time. And if you want to sign up for office hours, you can go ahead and do that as well. All right, guys, have a great day.